Welcome to New Orleans and to the 2016 Collegiate Wind Competition from the Department of Energy. 12 teams from across the United States will be competing over the next couple of days. Everything from tunnel testing, business plan, all fighting to win the championship.
We are Arctic Winds, and we're from University of Alaska Fairbanks.
I'm the faculty advisor for the Cal Maritime team.
I'm from the Universidad del Turabo, and I'm from Puerto Rico.
Puerto Rico is dependent pretty much on fossil fuels. 98% of the activity in Puerto Rico is fossil fuels.
The world has a problem with climate change and all those problems, so even if I only impact 1% more, it's just a little grain of sand.
This is an opportunity to have students at the university level to start working on renewables. Wind in particular, this is a great opportunity that we have with coming here to the competition. The first time we participate.
We focused on making our wind turbine specifically for Alaska, so the cold climates that they have. So there's no connection to power, and if the generator turns off, they don't have any power at all. So we're trying to focus it on being able to supplement that loss of power if it does happen.
They put a lot of work in this project. It was something really great to be part of, a great project to be involved with. They learn a tremendous amount. It's multidisciplinary. They learned about mechanical and the electrical stuff. It takes it much farther than our senior design takes it. I'd love to see some of them say, wind is cool and it provides, great benefits for our society and our planet.
These tunnels can go up to 29 miles per hour during the performance testing, and they only have 30 minutes to install, test, and remove their turbines from the wind tunnel.
The fact that we threw our turbine in there for the first time and for our first run, and it worked well, and it did what we thought it was going to do, and we didn't have to do a retest, so that was great. It was really good to go in there and see it's running, and the brake work, and everything ran smoothly. That was very exciting.
Yes, we've been having some trouble with the testing. That's part of the deal when you're doing a new engineering product. But this turbine is different from everything else that you see there, and it's something that they developed. And it's been evolving using engineering designs.
This is where the electricity is coming from. Exactly.
The blades are able to change their angle of attack as the turbine operates. And we do that in order to control the RPM of the turbine. Real world wind turbines, this is how they control their speed, and so we thought that this would be a way to elevate our design and get a little closer to real world turbine operation. We had it working perfectly at the beginning of the week, and the electronics have taken a dive on us a little bit, and so we've spent a lot of time over the last week pulling all-nighters, trying to figure things out and redo things, and up to this moment our star electrical engineer on the fly mechanical engineer is trying to redo parts of the board to get it to work here.
They've developed their business plan, they've established their business strategy.
There's probably more people here than live in Fairbanks almost. Come to a town of under 30,000 people, and then you come here and there's 2,000 people in one room. It's just it's a little different. It really helps you get used to talking to people and talking to businesses. Have never seen this many suits in one room, so they come up to you and shake your hands like, what, give them the spiel, give them your pitch, like, what do you hear, what are you doing, and it's really good practice so that you can get used to that networking.
Have over 12 million light bulbs in our island, consuming more than 40% of the electrical consumption of our municipalities.
Cal Maritime had a late game failure on their controller, and so for the last few days they've been trying to patch it together and fix it, and you just got a sense of how hard they were working by how little sleep they were getting.
We went back to the hotel and tried to write software most of the night and keep things going, and so we
sort of miraculously have a chance to do something in the competition today. And it may not be as polished as some other schools right now, but it feels like a huge accomplishment just to kind of stick with it and battle back from that. We're like right on the edge, man. We're right on the edge. But it's been fun.
These students represent our future. And as the energy mix in the United States changes for economic reasons, climate change, or energy diversity, these students are the ones that are going to make it happen.
As a group, just be really proud of what we've done so far. All the work you've done, all the things that you've learned, even just coming here, having kids from other colleges come and say, hey, that's so cool. How did you guys, thought about it? And even if in the time don't work as well as we expected before coming to the competition, we're going to take that as a big learning. And if we have another opportunity in the future, we're going to come back, and better than what we did this time.
Some of these teams are so compelling that you really believe that they're up and running. They truly are. They're meeting with the minister tomorrow. Whatever it is, these guys they've thought so much about the role that they're playing and the role they want to play in tomorrow's energy future that you believe them. That's what I find particularly fascinating and motivating and inspiring.
All right, our overall winner, Penn State University.